Hi, everybody. I'm sorry I was so late to class today. It was a total fluke, I guess. I was talking in my office. I didn't even realize it was already 11:15, and then I started walking over. So I apologize for that. It was okay that you left. I can understand why you did that. A few people stuck around, so I went ahead and taught a lesson. I wanted to finish chapter 5 today, and since you all weren't there for that, I wanted to go ahead and teach that lesson here, and I'll just post it on Blackboard, or at least post a link to it. Okay, so we're going to continue. We're going to finish chapter 5, section 5, and then we're going to do chapter 5, section 6. I actually cut out a pretty good portion of chapter 5, section 6, just because I just restricted it to the parts that we really needed. So we're going to start 5.5 by learning about scientific notation. So we'll go ahead and get started on the board here. Okay, so scientific notation, basically it's a way to write very large and very small numbers in an easy way by creatively putting the decimal point somewhere and saying, okay, so to put the decimal in a proper place that represents the number as given, um, we multiply or divide by enough tens. So anyway, so scientific notation is written as some number between 1 and 10 times 10 to some power. If it's a big number, that n is positive, like it's 10 to a positive power. If it's a small number, it's 10 to a negative power. So let's see an example. I should be on example 3 of 5.5 because we already did 2 prior examples in class. Okay, so we're going to put this very large number. In fact, I'll even put more zeros. So we're gonna put this very large number, 9,060,000,000 in scientific notation, and this very small number, 0.00018, into scientific notation. The idea here is that I'm going to put the decimal point after the first digit, so after the 9. So I'm going to write 9.066 here, because after that it's all zeros. And I'm going to say, well, if the decimal point is here, between the 9 and the 06, how many times am I going to have to move it to the right to create this big number, 9,060,000,000? Well, if you imagine that it's here, I would need to move it to the right 3 times to get to this comma, 3 more to get past this comma or to this comma, and another 3 to get to the end of the number. So I'm going to have to move it to the right 9 times. So we can illustrate that up here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so that's 9 times. And that enables us to create enough zeros, to create the 7 zeros after that 6. And so as a result, we say that this number, 9,060,000,000, is 9.06 times 10 to the 9th. Next, in part B, so I've got 0.00018. we're going to put the decimal between the 1 and the 8. Again, we're putting it after the first, I guess you could say meaningful digit, after the first non-zero digit. And we're going to say, well, over here in 0.0018, if the decimal were to be between the 1 and the 8, then to create this number, I would need to move it backward 1, 2, 3, 4 times. So let's do that. 1, 2, 3, 4. And that fills in the 3 zeros in front of the 18. Now, because we moved it 4 times, to the left specifically, we're going to multiply by 10 to a negative power. So this would be 1.8 times 10 to the negative 4 power. Now, on the other hand, it's possible for us to have a number that's already in scientific notation that we want to put into standard notation. In other words, make it look like a regular looking number. So let's practice that as well. Okay, so these numbers are already in scientific notation, and so we're going to put them in standard notation. Multiplying by 10 to the 6th means to move the decimal right 6 times. Multiplying by 10 to the negative 5th means to move it left 5 times. So let's see how this works. So starting with 6.27, I'm going to move the decimal point to the right here 6 times. So 1, 2, 3, 4, 5, 6. And then I'll fill in a bunch of zeros. So we'll label that 6 times. Remember, when you write a big number, you have commas every third digit. So after or in front of these zeros, and now in front of this 2. So 6.27 times 10 to the 6th is 6,270,000. In B, let's do the same thing with 1.08. So since we're multiplying by 10 to the negative 5th, we're going to move the decimal left 5 times. And of course, since I have all these blank spaces, I'm going to fill them in with zeros. So it looks like I have 4 zeros in front of 108. So I've got 0.0000108. And now I've written 1.08 times 10 to the negative 5th in standard notation, like a regular looking number. That concludes 5.5, and then I want to do a brief lesson on 5.6 as well, what I did in class, but what I did in class was brief. So I'm going to erase this. Okay, so in this section we'll talk about dividing polynomials. So specifically we're going to focus on dividing a monomial. Monomial means one term, of course. So let's look at an example. so we're going to divide these three. So it's just going to be the distributive property, but with division. Like when you multiply things by a single term, you just distribute that single term into the parentheses. Here it's just going to be we're dividing everything by a single term, so we're going to divide everything individually by that term. We're going to distribute division. Okay, so in A, I'm going to split up the fraction. So it's going to say 25x to the third over 5x squared plus 5x squared over 5x squared. Well, 25 over 5 leaves 5 on top. And then we're going to subtract the exponents. Well, 5x squared and 5x squared, they're exactly the same. So they just cancel each other out, leaving a 1. Little bookkeeping here, 3 minus 2 is 1. So I've got 5x to the first plus 1. In B, again, I'm going to split up the fraction into, this time, 3 parts. So 30x to the 7th over 5x squared plus 10x squared over 5x squared minus 5x over 5x squared. $30 and 5 cancel, leaving 6. And to do the exponents, I'll do 7 minus 2. 10 and 5 cancel, leaving 2. X squareds cancel completely because they're exactly the same. So I'm left with only 2. In the third one, 5's cancel completely. 1 power of x on top, 2 on bottom. So that's 1 minus 2. 7 minus 2 is 5. 1 minus 2 is negative 1. Finally, since we have an x to the negative 1 here, we're going to fix that by bringing x to the first downstairs. I mean, that's how negative exponents work. We switch their place in the fraction, and that makes them positive. So x to the negative 1 is the same as 1 over x to the first. Lastly, in C, we're going to split this fraction up. Okay, so everything is individually divided by 3xy. Well, 12 over 3 is 4. And to do the exponents on x and y, I'll just subtract top minus bottom. Six and 3 cancel to leave 2. X's and y's are exactly the same on top and bottom, so they cancel totally, leaving 2. Lastly, again, 6 and 3 cancel to leave 2. The y's cancel, so on top I'm left with 2, on bottom I'm left with x. Last thing to do is clean up 3 minus 1, which would be 2. So 4x squared y squared minus 2 plus 2 over x. Okay, so anyway, that's what we learned in class today. I made some slight alterations to the assignments in class. Or in class, I made slight alterations to the 5.5 and 5.6 assignments. So let me say what those are now. So for 5.5, the assignment is 1 to 75 odd, 81, 83, and 85 also. For 5.6, 1 to 11 odd, 33, 37, 43, and 49. Okay, so this is what we did in class today. Again, thanks for being patient with me. I apologize for being so late to class. So anyway, I'll see you on Tuesday. Oh, on next week Thursday, we've got our fourth exam. You probably have gotten the email that I posted the practice test and the key on Blackboard in course content. Okay, thanks a lot. Bye.